This is Algebra 2, Unit 5, Lesson 4 on Arithmetic Series. Now, a series is simply the sum of the terms of a sequence. The fundamental definition of a series is below. So, if the set A1, A2, A3 represents the elements of a sequence, so these are the terms of the sequence, first term, second term, third term, then the series, S of n, is defined by S of n equals the summation of the first term to the nth term of the sequence added together. So you're going to add first plus the second plus the third plus the fourth plus the fifth and so on until you get to n number of your series. Okay, so we've actually used these before whenever we have evaluated a summation problem. So let's see if we can work this out using this formula. Given the arithmetic sequence defined by a of 1 equals -2 and a of n equals a of n minus 1 plus 5, then which of the following is the value of s of 5 equals the sum of from 1 to 5 of a of I? All right, well, this is saying I want to add together the first through the fifth term of the sequence. So S of 5 is equal to A1 plus A2 plus A3 plus A4 plus A5, because I'm going from the first term to the fifth term. All right, so I need to know what my 5 terms of my sequence are. All right, well, I know what the first term is because A1 is -2. All right, now what is my next term of my sequence going to be? We need to get that from the recursive definition. So if I want to do the second term, I need to know the first term and add 5. So this is recursive, so we need to use the previous term. So a of 2 will equal -2 plus 5, which is equal to 3. So this term will be 3. So what should a of 3 be? Well, the previous term is 3, add 5 is going to be 8. For the fourth term, take the previous term 8, add 5 is 13. And then for the fifth term, you take the previous term, the fourth term, and add 5, and you get 18. So what is the sum of this sequence? Well, I add together -2 plus 3 plus 8 plus 13 plus 18. And my sequence should add up to 40. So S of 5, the sum of the first 5 terms of the sequence is equal to 40, which would be number 2. All right, now the sums associated with arithmetic sequences, which are called arithmetic series. So when you add an arithmetic sequence together, you get an arithmetic series. They have some interesting properties that can be predicted with what is commonly known as rainbow addition. So basically, you're making rainbows between your terms here. All right, so let's look at this arithmetic sequence and see if we can figure out the formula that gives us this arithmetic series. Given the arithmetic sequence defined by a of 1 equals 3 and a of n equals a of n minus 1 plus 2, the series based on the first 8 terms of the sequence is shown below. Okay, so terms have been paired off. So let's remember what our series is. What's the first term is 3. And then how do you find the next term? You take the previous term and add 2 to it. So 3 plus 2 is 5, 5 plus 2 is 7, 7 plus 2 is 9, 9 plus 2 is 11, and so on. Okay, so given this sequence of 8 terms, what does each of the paired off sums equal? So we go 3 to 17. What does that add up to? Adds up to 20. 5 and 15 is also 20. 7 and 13 is 20. 9 and 11 is all 20. All right, so why would this sum be constant? Well, when we are going this way, from 3 to 5, to go from the first term to the second term, we are adding 2. So when you're moving in this direction, you are adding 2 and you're increasing the value. Now, if I'm pairing this up with 17 and I'm going to 15, what's happening here? You are subtracting 2. So going this way, you are subtracting 2. So this sum, adding and subtracting 2, it's going to leave the sum to be a constant value because you are not increasing by any other value. Plus 2 this way, minus 2 cancel each other out. So the sum is constant. Okay, so how many of these pairs are there? Well, I've got 1, 2, 3, 4 pairs. All right, because there will be 4 pairs because there is 8 elements in the set, or 8 terms in the set, and I pair them up divided by 2, I end up with 4 pairs. All right, so using your answers to A and C, find the value of the sum using a multiplicative process. Okay, so what was my sum? My sum was 20, right there. How many pairs of 20 do I have? I have 4 pairs of 20. So what should the sum of the sequence be? It should be 80. Okay, so just to check and make sure we're correct, 3 plus 5 plus 7 plus 9 plus 11 plus 13 plus 15 plus 17. So there's the 8 terms, equals 80. Look at that. So if we know the formula for the sum of the arithmetic series, using the shortcut, we can figure it out quickly without having to simplify or simply add each number as we go. So let's see if we can figure out the formula and generalize the formula. Okay, so create a formula for an arithmetic series sum based only on its first term, a1, its last term, a of n, and the number of terms, s, and number of terms, n. All right, so let's think about what we just did. S of n would be the sum of the series. All right, so the first thing we did was we matched up the sums. Okay, we made the pairs. So the pairs were made up of the first and last term of the series. All right, so the first term of the series would be, or sequence, excuse me, would be a1. Now, if n is the number of terms of the sequence, what would be the last term of the sequence? It would be a of n. All right, so that's my sum. All right, and then how do I figure out how many pairs I have? Well, I took, this one had 8 terms, and I divided it by 2. So it depends on the number of terms that you have. So it would be n is the number of terms divided by 2. Okay, so let's review. N is the number of terms of the sequence. Okay, this n divided by 2 is the number of pairs. Okay, a1 is the first term, and an is the last term. Okay, so to find the sum of an arithmetic series, you add the first and last term and multiply it by the number of terms divided by 2, and you've got it. So there's your formula. All right, so here is our formula again. Given an arithmetic series with n terms from a1 to an, then its sum is given by s of n equals n over 2 times a1 plus an. All right, so which of the following is the sum of the first 100 natural numbers? Show the process that leads to your choice. Okay, so we need to fill in what n, a of 1, and a of n are in order to figure this out. So we are looking for s of how many numbers? 100. So s of 100. So n is going to equal 100. Okay? So that will equal n, we just said was going to be 100. So there's actually going to be 100 divided by 2, which is going to be 50 pairs. Okay, now we need to know the first and last term of the sequence. All right? The natural numbers is how you count when you're in kindergarten. What is the first natural number that you learn when you count? Well, it's going to be 1. Okay, now if you're going to the first 100 natural numbers, what would be the 100th natural number? Well, it would be a of 100 would be 100. Okay, so to figure out what the sum of those numbers, if I added from 1 to 100 as natural numbers, added them all together, 100 divided by 2 is 50, 1 plus 100 is 101, and then 50 times 101 is 5,050. So s of 100 is equal to 5,050. And we got it. So there we go. So if you were to add up the first 100 natural numbers starting at 1, then you would end up with 5,050. Handy. Rather than having to type them all in your calculator, that goes really quickly. All right, so let's find the sum of each arithmetic series described or shown below. All right, now just for my purposes, because you have it at the top of your screen and I can't see it, remember your formula is s of n equals n over 2 times a1 plus an. There's my formula. Okay, the sum of the 16 terms given by. Here's my 16 terms. Notice there's dot, 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 so not all of them are listed. Okay, so the sum of the 16 terms, so s of 16. So n is going to be 16, so it's 16 divided by 2. The first term is going to be negative 10, and the last term is going to be 50. So this is a1, this is a16. Okay, and there would be 8 pairs. Negative 10 plus 50 is 40. So S of 16 is equal to 320. So the sum of those numbers right there, if you'd had all 16 terms, would add up to 320. Okay, now let's see what we can do for this one. The first term is -8, the common difference D is 6, and there are 20 terms. Okay, so we are looking for the sum of 20 terms. So N is going to be 20. All right, so 20 divided by 2. We know the first term is -8. Okay, problem. Do we know the last term? No, we don't. We need to know the 20th term of the sequence. All right, so we need to find A of 20. Now remember, this is an arithmetic sequence. Remember our formula for an arithmetic sequence. A of n is equal to A of 1 plus n minus 1, one term less than the number of times that you add the common difference, D. All right, so there's my formula. So if I'm doing the 20th term, I need to know the first term, which is -8. How many times would I have to add 6 in order to get to the 20th term if I'm on the first term? I'd have to add it 19 more times because it would be n minus 1. This is 20. This would be 19. Okay, so that gives me -8 plus 19 times 6 is 106. Make sure. 19 times 6. Or 114, I'm sorry. 114. And that's 106. So A of 20 is equal to 106. So I needed to know what the 20th term was before I could figure that out. So that's going to be 106. So we had to use our arithmetic sequence formula to figure that out. So let's final answer. 20 divided by 2 is 10. -8 plus 106 is 98. So the sum of the first 20 terms, 10 times 98 is 980. Okay, so that one took a little thinking because we had to figure out what our term of our sequence was. Now, let's try another one. The last term is A12 equals -29, and the common difference D is -3. Okay, so how many terms are in this sequence? There's going to be 12 because this is the last term. A of n is going to be 12, so we're looking for S of n is going to be S of 12. All right, do we know the first term? No. We know it's going to be 12 divided by 2, but we don't know the first term yet, but we do know the last term is going to be -29. So we have to figure out our first term of our sequence. So we need our sequence formula, A of n. So we are looking for A of 1, we know A of 12. All right, and that is equal to A of 1 plus n minus 1 times D. Okay, so we're looking for A of 12, so A of 1, A of 12 is -29. A of 1 is what we're looking for. Now, if we're on the first term, how many times do we have to add to get to 12? We have to add 11 times what common difference? -3. So that gives me -29 equals A of 1 minus 33. So if I solve this for A of 1, add the 33, A of 1 would have to be 4. Okay, so my first term is going to be 4. All right, so that would go here. So S of 12 is equal to 6. 4 plus -29 is -25. 6 times -25 is -250, or 150. It's -150. Okay, so you have to use the sequence formula in order, the arithmetic sequence formula, to figure out the term that you need. Okay, so let's save letter D and exercise 5 for the next class.